Hello students, I am Sachin Prakash and I teach and mentor students in chemistry for IIT. I believe that the real confidence which is required to crack this IIT exam will come only when you are confident in tackling good problems. And that clarity and understanding of concepts will only develop when you are really comfortable in handling these problems. So this video contains the paper discussion which I have conducted in my uh, classes online. Okay, and a lot of good doubts are there which I have discussed here. It will be helping you people in understanding, developing an understanding in how to approach and tackle good problems. Okay, and if you like this, if you found this paper discussion video to be useful and interesting, you can, like, comment, and subscribe to this channel, which will surely, motivate me to add some more useful videos of this type. Okay, because ultimately it's, this is just an effort, honest effort, small honest effort from my side to help the student, uh, help my students as well as other students also in their ITJ preparation. So let us begin with this paper discussion. Okay. Okay. So good evening, students. We are going to start UTM 10 paper discussion. Okay. And this is based on GOC, tautomerism, and I'm just muting everyone. GOC, tautomerism, alkanes, and half of alkenes. So as usual, we'll be starting with the numerical value questions. So question number 71 to 73. What are the doubts? 71 to 70.
In 71, how cyclopentadiene, sir?
Cyclopentadiene, you see, I have given this in the notes also. If a hydrogen is said to be acidic, if it is connected to a highly electronegative atom, okay, or it is between two electron withdrawing groups, or it is giving on removal of that hydrogen, you get an aromatic carbonyl. Are you getting a point? Yes or no?
Yes, sir.
So that is why. Others are clear, or even in case of alkynes. Okay, terminal hydrogen of alkynes is acidic because sp carbon is more electronegative than nitrogen. Is it clear? Yes or no?
Yes, sir.
That's very good. So 71 is clear to all of you?
Yes, sir.
Yeah. Then after that 71, I think 72 is also a doubt.
Yes, sir.
Can you draw the
Yeah. So you see, this is like your C3CH2Br, and this is CH3CH2CH2Br. Okay, now when you are having Woods reaction, what you do is you first generate the radical R dot. So you get this radical and this radical. Is it clear? Yes or no?
yes,
sir.
Now you see, radicals can undergo two types of reactions. First is coupling, second is redox reaction or disproportionation reaction. Okay, so when you're talking coupling, these two can couple. So if these two are coupling, then you will be getting this one. Are you getting a point?
yes, sir.
Okay, if these two are coupling, you are getting this two. This is self-coupling. You will get this. There's a 3 carbons, so 3 plus 3 is 6. And if there is a mixed coupling, you will get 5 carbon hydrocouple. Is it clear?
Yes, sir.
Okay. Apart from that, you'll get disproportionation reaction product. Now, first we'll talk about self-disproportionation. So, self-disproportionation, if you're doing for CH3, CH2 dot, Okay, then what will happen? That this is reacting with, you can visualize this to be reacting with this. So if this take this hydrogen and this dot is there, then you'll be getting CH3 like this. Two unpaired electrons on adjacent carbon will form a pi bond. Is it clear?
Yes, sir.
Similarly, if you are having CH3, CH2, CH2 dot, okay, then and it is reacting with CH2 hydrogen, CH2, CH hydrogen, CH2 dot. Now you see there are two options here. If this takes this hydrogen, okay, then you will get a dot here, right? And something like this. And if it takes this hydrogen, it will be forming an alkene like this. Yes or no?
Yes, sir.
If it forms this dot, then it will close the ring to become a this type of thing. Three-membered ring. Are you getting a point? Is it clear? Yes or no?
Yes, sir.
Yes, sir.
So total it will be 4 plus, so it will be 3 here. Okay, this is same as this. So here it is 3, here it is 2. Okay, so 3 and 2, 5, and 3, 8. Okay, so they have given 7, no? This means they are not considering this one. Are you getting a point? But there is a possibility of formation of cyclopropane also. Getting a point?
Yes,
Yes,
sir.
sir.
Okay. So that is how they are getting 7. Is it clear? Yes or
Sir,
no?
generally we should consider cyclopropane, sir.
Means cyclopropane is unstable. So possibility of that forming might be less. See, if you are starting to consider those probabilities, then a lot of other things will start happening. Okay. So you can ignore the cyclopropane part. Are you getting a point? Okay.
Yes, sir.
So if you just remove this, you'll be getting an answer to be 7 only. Is it clear?
Yes, sir. Yes, sir.
Okay. After this,
Sir,
yeah.
sir, when I did it, I was getting 7 only, including that cyclopropane. Can you just say once where that extra one is? I mean, I was getting only 7.
Well, you see, 3 3 you are getting like this. Okay. Then self, self disproportionation of ethyl radical will give these two. Yes or no?
Yes, sir.
After that, if you are doing disproportionation of this, okay, if it takes this hydrogen, you will get this and this. Getting a point? So total it will be 7 only. If you are taking cyclopropane, then it will become 8. Getting a point? Yes or no?
Sir, why should we not consider cyclopropane?
Means because generally it is unstable, so that is why. Because if you start comparing, like including that, then you it will open a door to a lot of other products also. Are you getting a point?
Yes, sir.
Like this radical can react with this alkene to give a longer chain radical. Getting a point? So that way, so generally they are considering the stable production byproducts only. Are you getting a point?
Yes, sir.
Okay. So 73 answer should be 4.
Yes, sir.
Because I have told you Hoffman's product is for spherical poor leaving groups Okay. Then sterically hindered base and sterically hindered bromide ion. Are you getting a point?
Yes, sir.
Yeah, sir.
The beta hydrogen is sterically hindered here. So it will go for this beta hydrogen. The answer should be 4. Is it clear?
Yes, sir.
Yes, sir.
Okay. Technically speaking, I am expecting that someone might, if a bigger, some higher faculties will agree, they might put cyclopropane, but for 72, I am feeling that the answer will be 7 only. Or if they are ready to put cyclopropane also, then answer can be 7 as well as 8. Are you getting a point?
Yes, sir.
Okay, but from stable byproducts point of view, the answer should be 7 only. Okay. Now, after that, so 73 is a key change. Answer should be 4. Okay.
Sir, can you explain this once again?
See, Hoffman's product. I have discussed Hoffman's elimination, no?
Yes, sir.
So what are the conditions for Hoffman's elimination? See, Hoffman's elimination is an E2 elimination only. Okay. But it is taking place when you either have a poor leaving group like fluorine or NMe3 plus, or you are having a sterically hindered base or sterically hindered beta hydrogen. If you remembered, I gave this example, something like this. So actually, it is the same example which they have given here. So here, instead of this hydrogen is more preferred. Is it clear? Because
Yes,
this group will be blocking the access of base towards this hydrogen. Okay? Answer should be 4. 74, 75.
Sir, Wi-Fi, can you say?
See, in 74, the this carbon, the stereochemistry is already given to be fixed. Okay, so if you draw the wedge and dash representation, the chlorine should be up, right? Sorry, chlorine should be down the plane, because if you draw a line and draw a Fisher projection, okay, it will be looking like this only. Getting the point? Yes or no?
Yes, sir.
Now, the second chlorine can come at these positions. Yes or no?
yes, sir.
Okay. Now, so I am putting it one by one. For the first, the chlorine is here. Now you see, this is it is already a chiral center. Here also it is a chiral center. But since this chlorine is fixed, it is representing a single product. Are you getting a point? Because other configuration is not possible. Is it clear?
Yes, sir.
Okay. So only one for this. Second case, if the chlorine is here, it does not remain a chiral center. So again, one product. Clear? Yes or no?
Yes,
In this case, again, there is no chiral center if it is here. So again, one. Okay. And in this case, you see, if we are putting a chlorine here, this becomes a chiral center. Okay. Now here, this group can be, this is down. Okay. This group can be up as well as down. So you will get down up and down down stereoisomers. Are you getting a point?
but since they said that it is fractional distillation, stereoisomers, we consider it as one fraction, right?
No. What we are saying is that these are diastereomers. For each of them, you will again get D plus L. Are you getting a point?
D and L should be considered as one, but here D and up, down and up and down and down. That should be considered different, yeah?
Yeah, because they are diastereomers, no?
Yes, sir.
So that is why. Is it clear?
So even the other carbon with chlorine is also chiral, right?
See, these two carbons are equivalent, no?
The other one, sir, with chlorine.
Which
The
one? This one? This
yes.
one? This is a, if chlorine is here, it's not a chiral center, no? So it is
Sir,
one
can you
on.
just show where you're pointing?
Huh?
Can you show where you're pointing at which chlorine?
This one.
No, sir, I'm talking about the fourth, last example.
Yeah. In last example, this chlorine and this, sorry, this carbon and this carbon are equivalent. So you can put chlorine at any one of them.
Yes, okay.
Okay, so if you are considering this to be a parent chain, okay, and let me just draw it. Oh, something like, if you're considering this to be the parent chain, then okay, you will be having chlorine like this, okay, and say this is like like up, like dot 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 dot. Then this chlorine will be, this CH2Cl will be like this, okay, and if it is down, it will be something like this. Getting a point?
Yes, sir.
So these two will be diastereomers. Getting a point?
Yes, sir.
Yes, sir.
That's very good. So this question is clear to all of you? How answer is 5?
Yes, sir.
That's very good. So 75,
No doubt.
75 is clear? Okay. Yeah, in numerical value, I expect that 72 and 74, that are confusing. Is it clear? But 73 is easy. How many of you have answered 4?
Yes, sir. I did.
Okay, then you should be getting marks for that. That's very good. Okay, so do these two questions Actually, if since I was not there last week, but I think I have discussed this question in the notes. 72, is it there? I think
Yes, sir.
it is there in the notes. Okay, even though I have not explained it because I was not there, it was there. So if you had gone through the notes properly, I think the teacher didn't cover it.
We covered it, sir.
Then it is good. You should be answering this question, no? Okay, so after this 70, 70, is it a doubt? No.
Sir, explain, sir.
70. See,
Yes,
you see, in 70, this is an electron withdrawing group. So it will destabilize the negative charge. Okay. So in this case, this will destabilize through plus I effect. There it is, destabilization is a plus M effect. Okay. So, 1 minute. So I think that and you are also having what you call as, okay, here you have to use this part. I think I have told you people that benzoic acid is more acidic than acetic acid, right? Is it clear?
yes, sir.
Yes, sir.
Okay. So even if you add an electron with donating group to benzoic acid, okay, and a CH2 group here, benzoic acid will be still greater than acetic acid. Now this is something which you cannot explain through, logic, because there are two competing effects here. One is the cross conjugation provided by the benzene ring, and second is the minus I effect provided by the benzene ring as well as the OMe group. Are you getting a point? But overall effect should be, increasing the stability more for 3 than 4. So 3 should be greater than 4 here. Between 1 and 2. Okay, now you see 1 and 2 both are having less cross conjugation than 3. Okay, plus 1 is having sp carbon, so its minus I effect will be more than sp2 carbon. So 1 should be greater than 2, greater than 3, greater than 4. Are you
Sir,
getting
once
a,
can you say
Difference between 2 and 3.
again?
yeah? See, here there is less cross conjugation and less minus I effect. Okay, so here between 3 and 2, see 1 will have maximum because of sp carbon. The minus I effect is very high. Are you getting my point?
Yes, sir.
Between 2 and 3, you see you are having a single vinyl group and you are having an electron donating phenyl ring. So here, see, there is no way of actually comparing these two effects. Okay, but if you check the values, 2 will be more than 3. Getting a point?
Sir, in 3, if that OCH3 was not there, then 3 would be greater than 1.
No, still I think if we talk about, let me give you the values. Okay, if you talk about this is like 1, 2, 3, so it's like 2 propanoic acid. Okay,
Sir,
just yeah.
between 3 and 4, plus M effect should be greater than plus I effect, no, sir? But we know that plus M effect is more than plus I effect, no, sir?
See, what am I saying is that in these cases, you cannot actually predict the order based on the logic of the effects, because there are two effects which are opposing each other. Are you getting a point?
Yes, sir.
Okay, so I'm just giving you the pK values. For pK for this is like 4.25. Okay, and pK for paramethoxy benzoic acid is 4.37. So there is no way of, without pK values, you cannot do this question. Are you getting a point? Because
Yes.
the values are very close to each other. Is it clear? See,
Yes,
with
sir.
this, the advantage is that it is having like a more number of sp2 carbons, so more minus I effect. But at the same time, OMe is plus M, so it is decreasing, destabilizing the NR. So overall effect is difficult to predict without knowing the actual values. Getting my point?
Yes, sir.
Yes, sir.
Okay. So this is a question which is like you are not supposed to, without the values you cannot do this question. Okay. So after 70, 68 and 69.
68, sir.
68.
68. Now you see, I think I have discussed this part that if you are having CS3, and you are treating it Br2, what will happen that this will attack here, this will go out. You'll be getting cyclic bromonium and yes or no?
Yes, sir.
Okay. Now you see, if you are using Br minus, it will attack here, ring will open. If you are also having Cl minus, then this will also attack here and this will open. Getting a point? So you will see it will depend on how many nucleophiles are available. Are you getting the point? So you will be getting this plus this as product. Are you getting a point? I think I have discussed a slightly better version of this where I have also included aqueous NaCl. So in that case, you will also get a version which contains. Are you getting a point? Yes or no? But since here water is not mentioned, only these two products will be there. Getting a point?
Yes, sir.
Okay. Then
Sir, 67.
67 is something which I have discussed in the class notes as well as in the class also. You see, if I'm talking about, I'm drawing it slightly different. You see, hydrogen can be attacking from up, hydrogen can be attacking from down. So if it is attacking from down, then this CH3 will be what? Up? Then you will be getting up as product. And if it is acting from up, then this CH3 will go down. So you will be getting down as product. So these two are what? Diastereomers. Getting a point?
Yes, sir.
Okay. After this, 66. See, you have to just see for the compounds which contain only one type of beta hydrogen, which is 4 and 2. Getting a point?
Yes, sir.
Okay. 66 is done. So 64 and 65. Any doubts? I think we have discussed this in the class. Same
Yes.
question. Okay. This also we have discussed in the class.
Yes, sir.
Okay. Then 61 to 63.
So once can you show 64?
You see, this is the bromine, right?
Yes, sir.
Now this bromine is up. So it requires a beta hydrogen which is anti, which is down. What are the beta hydrogens? This and this. So what are the only this beta hydrogen is there. Here you have CS3. So here this CS3 cannot undergo elimination. So this hydrogen has to go. If this hydrogen goes, you get a pi bond here, and CS3 will be down. So you see pi bond and CS3 down. Second is the answer. Is that clear?
Yes, sir. So once can you say like how to remember whether we require a like down one or up one, that one?
See, it is anti-configuration now. So if the leaving group is up, you have to look for the down configuration. Getting a point. There is nothing to remember here. Anti means if the orientation of the leaving group is up, you have to look for down. If the orientation of leaving group is down, you have to look for up beta hydrogen. Is it clear?
Yes, sir. Okay.
Okay. So after that, 62, I think I have discussed in the class.
63, sir.
63? No, 62 I have not discussed. 63 I have discussed in the class.
Yes, sir.
Yes, sir.
62 is a fact-based thing. You see, since the 3-degree hydrogen is, pretty CH bond energy is less. So here the oxygen, if you are treating it with a alkaline KMnO4, okay, a BS reagent, then this will undergo oxidation to OH. Okay, it's a fact-based thing. Is it clear? Yes or no?
Yes, sir.
Okay.
Sir, 60, why not that mixture of A and B?
See, first you will get this carbonyl. Okay. And then this will take an acidic hydrogen, which is this one. So there is no scope of D, no. The carbonyl, the negative charge is not delocalized here. You are not having a base which is taking the acidic hydrogen. Are you getting a point?
Yes, sir, okay.
$56, sir.
56. Yeah, 56. You see, first the atomic factors will be in picture. Negative charge is more stable on more electronegative atoms. So O minus will be more stable than C minus. Are you getting a point?
Yes, sir.
So X will be more acidic than Y and Z. Now between Y and Z, you see, if you are considering the negative charge here, okay, and you're trying to delocalize it, it will go like this. But here, okay, so it will go like something like on this. So this OH lone pair will be destabilizing the negative charge. Are you getting a point?
Yes, sir.
Okay. But if your negative charge is here, then it will go like this to NO2. So it will be more stable. Are you getting a point?
Yes, sir.
So Y will be more acidic than Z. Okay? Yes or no?
So once again, can we repeat for Y and Z?
Okay. You see, this OH will be creating a negative charge here. Okay. So if the Z is having a negative charge here and it is getting delocalized, then there is a negative charge coming here. Yes or no?
Yes, sir.
So these two negative charge will destabilize each other.
Yes.
Okay, so the delocalization of Z will be less.
Okay, so got it.
In this case, NO2 will create a positive charge here. Negative charge delocalization will create minus here. Minus plus will stabilize each other. Is it clear? All of you?
Yes, sir.
Okay. 55.
No doubt.
53, 54,
No doubt.
Sir.
Sir, 53, 1 and 2.
53, 1 and 2. Okay. So you say you 53. I have told you the COH group is less acidic than SO3H group. Always. So here we are considering acidity of this. Here we are considering the acidic hydrogen from this. So this is always more acidic. Getting a point?
Yes, sir.
Okay.
So here, why can't we consider like
Why are we not
both
taking
COH is common,
NO2?
no, sir? NO2 we
Because
have to
if you are
take.
talking acidic strength, you are talking about the most acidic hydrogen. In this molecule, the most acidic hydrogen is this, but in this one, the most acidic hydrogen is this one.
Okay, sir.
They are not asking you to compare the acidity of carboxylic acids. They are asking you to complete the acidic strength of the given compound. So you have to select the most acidic hydrogen of that compound. Is it clear?
Yes, sir.
Yes, sir.
Okay. Now 51, 52. Is there any doubt?
52 you explained so much.
52, you see, this I have discussed in the class also. You see, this is a sp2 nitrogen, sp3 nitrogen. This is a localized sp2 nitrogen. Here, you see, here you have a sp2 nitrogen which is localized, but then if you, and here also you have a sp2 nitrogen which is localized. But you see, here if you do a protonation and you get a positive charge, then this positive charge is delocalized to this nitrogen. Are you getting your point?
Yes, sir.
Okay. So sp2 nitrogen, so here the cation is getting stabilized. Here the cation is not getting stabilized because this positive charge cannot move anywhere. Here also the positive charge, the moment you put a plus here, it can be delocalized to this. It can also be delocalized to this. Getting a point? So 4
Yes.
in fact will be most acidic, then 3, then 1, and then 2. Because sp2 nitrogen is less basic than sp3 nitrogen. In both cases, the charge is localized. So if the cationic positive charge can be delocalized, acid basicity will automatically increase. Is it clear?
Yes, sir.
Yes, sir.
So 52 is done.
Yes, sir.
So I think this whole paper discussion is complete from
Sir,
this side. Yeah,
can you give the structure of cresol, sir?
this is the structure of cresol.
Yeah, sir. Okay.
So this is orthocresol, meta, para you can draw yourself.
Yes, sir.
Okay. Anything else in this paper? Yes, no.
So once again show 54.
54. Yeah. This is also something which I have discussed in the class. If you look into the notes. See, this is a sp3 lone pair. This is a sp2 lone pair. Both are localized. This is a sp3 lone pair, but a minus I effect. And this is a delocalized sp3 lone pair. So four will be, if I am writing the acidity, basicity, fourth will be least basic. Is it clear?
Yes, sir. Okay.
Okay. So I think only one option is, no, not one option. I think 1 and 4 both are there. Now, when you're talking about the most acidic, okay, then you see 1 and 3 both have sp3 lone pair. But so it will be more acidic than sp2 lone pair. So second will be second least. Between 1 and 3, the conjugate cation will be more stable in 1 than in case of 3. Is it clear?
Sir, in 2, the lone pair will get delocalized.
No, the lone pair is still localized only. It's a localized sp2 lone pair. But you see,
Okay.
sp2 lone pair is less basic than sp3 lone pair if both are localized.
Yes.
Because sp2 nitrogen is more electronegative. So its basic tendency is less. Is it clear? Yes or no?
Yes, sir.
Yes,
Sir,
sir.
one say between 1 and 3, no, sir?
Hmm?
Between 1 and 3.
Yeah, in between 1 and 3, you
Yes, sir.
see, if you're talking about between 1 and 3, you see the, if you draw the cation here, then you put a positive charge here, put a positive charge here. The oxygen will be destabilizing the positive charge for minus alpha. So 3 will be slightly less basic than 1. Getting a point?
Yes, sir.
Okay. Anything else which you feel
Sir,
needs to be?
59.
Huh?
59.
Yeah, rate of decarboxylation is directly proportional to the stability of the negative charge. Put the negative charge by removing this. So in first case, the negative charge can be delocalized, right?
Yes, sir.
I have given this point that the rate of soda lime decarboxylation is directly proportional to the delocalization of the stability of carbon ion. Carbon ion will be more stabilized in this case. Getting a point?
Yes, sir.
Yes or no?
Yes, sir.
Any other point which you want me to discuss? Or is it done? Are you clear with all the questions? Yes or no?
So 55th one, can you say?
You see, if you make an anion out of it, then the presence of a COH which exerts a minus I effect will stabilize this anion. In this case, only hydrogen is there, it does nothing. So both 1 and 2 will be more than 3. Getting a point?
Yes, sir.
And between 1 and 2, I have told you that 1 will be more, the anion will be stabilized by intramolecular hydrogen bonding.
Yes, sir, got it.
That's it. Any other doubts in this paper?
So once again, can you explain 74?
Yeah. See, here they have fixed the orientation here. They are only taking one of the enantiomers of this compound. Getting a point?
Yes, sir.
So that enantiomer I have shown by this line, the back wedge or downward.
Yes, sir.
Now you see, you can have 4 different positions at which you can do chlorination. So each one I have shown. Are you getting a point? In the first case, you are getting only one product because this is the stereo center, but here the configuration is fixed. You cannot change this configuration. Getting a point?
Yes, sir.
Here there is no chiral center, so what? Here also only one chiral center whose configuration is fixed, so one only. In the last case,
Yes.
you are getting a creation of new chiral center at this point because of chlorination. Now this configuration is fixed at down, but this can be up as well as down with respect to this one. So you'll have 2 stereoisomers.
So once again, can you say the last one?
What I am saying is that this is what? This is down. Yes or no? Now with respect to
Yes,
this,
sir.
this can be up or this can be down because here there is a new chiral center created. So it can be, this can be up or down the plane. Yes or no?
Yes, sir.
So you get a down up and a down down stereoisomer. Yes or no?
Yes, sir.
So these two will be diastereomers.
Yes, sir. Understood.
That's good. Any other question which is a doubt?
So 63, we just have to remember.
63. This is something which I have discussed in the class. That all catalytic hydrogenations will be same and Birch reduction will be trans. I have given the mechanism also.
Yes, sir, but that Na and Ni I got confused and I put Ni.
Oh, it's okay.
Yes.
Sodium in liquid ammonia, okay, and PTPSO, it's okay. Okay, this is not a very big mistake. Is it clear?
Yes, sir.
Okay. See, it's not like you are supposed to, simply you are accurate, it is good thing. But do not beat yourself too hard if you are not committing some minor mistake. Keep in mind that you made this mistake, write it down somewhere. Next time revise it so that your mind is conscious of not repeating that mistake. Is it clear? So do
Yes,
not
sir.
be so much, bashing yourself for this small mistake. Okay? Any other doubt? Yeah, if there is a conceptual mistake, then you should be keen to rectify it. Is it clear?
Yes, sir.
Yes, sir.
Okay. So with this, I feel that the paper discussion is done, right?
Yes.
Yes, sir.
Okay. So best of luck for tomorrow's exam. Okay, do well, and we'll have a paper discussion on Monday. Okay.
Okay, sir.
Okay,
Okay,
sir.
sir.
Okay. Next week we are supposed to finish the whole alkenes. Okay, alkynes. Sorry, alkenes only. Okay. So give the exam. See, I don't think they have asked enough questions from, reaction of alkenes also. Mostly
Yes,
the
sir.
preparation part they have asked. So prepare accordingly. Okay. Anyways, we have finished everything which is there in preparation of alkenes. Okay.
Yes, sir.
So with this, I'm ending today's paper discussion. Thank you people for attending today's paper discussion. Okay.
Thank you, sir.
Thank you, sir.
So I'm ending the paper
Thank you,
discussion.
sir.
Thank you, sir.
Yeah. So I'm stopping the. Now we are live, and today we are going to start the paper discussion of this paper, UTA 10. Okay, this paper is based on GOC plus tautomerism plus alkanes and half of alkenes. Okay. Now, 19, 20. Any doubts?
Sir, 19C.
Yeah, this we have discussed in the class now. Here the lone pair is localized due to inversion, lack of inversion.
Sir, but that lone pair cannot be denoted, no, sir. It can.
Yeah, it can be donated, no?
But that bridgehead,
Bridgehead
I mean,
carbon cannot take a positive charge. Nitrogen bridgehead, if it takes a positive charge, it will be a sp3 nitrogen only, no?
oh, okay, sir. Yeah.
This I have discussed in the class also. Okay. Apart from that, others are clear?
Yes, sir.
After that, question number 20. No doubt.
Can you explain this resolvable and non-resolvable?
You want me to explain this?
Yes, sir.
Okay. How we are going to do this question is that you see, you have doing Br2CCl4. Now you'll be getting something like this. It has got only one chiral center. Okay, getting a point. So it will be D plus L. Yes or no? Now this is a trans alkene. Okay, and again you are having this. This is anti-addition. So trans plus anti, you'll be getting what? Erythro. Yes or no?
Yes, sir.
So it is non-resolvable. Yes or no? Number C, one gives different products with HBr. See, only unsymmetrical alkene will give Markovnikov and anti-Markovnikov as per presence of peroxide or absence of peroxide. Is it clear? Yes or no?
Yes, sir.
And In case of 2, it is a symmetrical alkane. Both sides you have CH3 only. There is no regiochemistry in this case because both sides are same. It can attack any of the 2 terminals. Is it clear? So D will give same product whether it is in presence or absence of peroxide. Is it clear? Yes or no?
Yes, sir.
Okay. 21, 22. Question paper is good. 21, 22.
Sir, 22 option 1.
22 option 1. Ortho effect means that ortho substituted benzoic acid will have higher basicity than benzoic acid itself. Okay, so this will be higher than COH. These two will be having lower than COH. In fact, it will be something like this. This is 1, then this is 2, then this is 3, 4. Are you getting a point?
Yes, sir.
Ortho effect, direct application as well. So you see, ortho effect says that ortho substituted will be more acidic than parent benzoic acid. So from that you can, deduce that. Is it clear?
Yes, sir.
Yeah.
Sir, option C also, please.
Option C. You see, in this case, carboxylic acid is there, phenol is there, and CH3 is there. So you see, carboxylic acid will be, the anion will be more stable here compared to here, and in this case it is negative charge on carbon, it will be least stable. Is it clear?
Yes, okay.
Okay. So I think 22 is done. 21 and 22. Yes or no?
Yes, sir.
That's very good. Okay, so let's move forward and 23 and 24.
So 23 option A.
23 option A.
Those 2 extra, can you see?
Yes, 23. Let us try. Okay. You see, CH3. If you are doing monochlorination, what are the options? Chlorine can come here, 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 okay, here, and here. Yes or no?
Yes, sir.
Draw all them. Okay. Then these are the options. Yes or no?
Yes, sir.
Yes, sir.
Now let us start evaluating the stereoisomers. Okay, this will have only one. Yes
Yes,
or no?
sir.
This will be having only one.
Yes, sir.
Okay. This will be having, you see, you can have up, up and up, down.
Yes, sir.
Okay. And both will have 2 each. Because there is no plane of symmetry.
Yes, sir.
Yes, sir.
Okay. Then in this case also, up, up, down, 2 and 2. Because D or D plus L for each of them. Is it clear?
Yes,
This
sir.
case,
Yes.
it will be always a plane of symmetry passing like this. But geometrical isomerism is that up, up, and up, down. Total will be how much? Can you see? S12?
Yes,
Yes
sir.
or no? Talking about fractions, what is the fractions? Okay, let me. There is one fraction here, one fraction here, two fractions here, two fractions here, okay, and two fractions here. Total fractions will be 8. One DL pair is one fraction. Is it clear? Yes or no?
Yes, sir.
Yes, sir.
Okay. Option C, out of all monochloro products, structure isomer level only. Only 3 are capable of showing geometrical isomerism. That is correct? 1, 2, 3. Yes or no? Getting a point? Yes or no?
Yes, sir.
And of all monochloro products, only 2 can show chirality. Only 2 of them can show chirality. This one and this one. Right? Again on the structural isomer level. Getting a point? Yes or no?
Yes, sir.
Yes, sir.
So are you happy with this question now?
Yes, sir.
Okay. Can you move forward?
Yes, sir. Yes, sir.
Okay. 24 is also a doubt.
No, sir.
In 24, you see, I have given the soda-lime decarboxylation. RCOH gives RCO minus, which gives R minus, and then it takes H. You see, the carbon ion here can undergo resonance in 2 different forms. Are you getting a point? This can be delocalized to here. So here it can go up, down. Okay. So there will be a chiral center here, so 2 isomers here, and here it can go cis trans. Is it clear? Yes or no?
Yes, sir.
That's good. So moving forward, 25 is not a doubt.
No,
No,
sir.
sir.
Okay. Then 26, 27, 28.
$28, sir.
28. See, in this case, when you have Hoffman's elimination, your carbon ion will have a transition it's an E2 elimination. Yes or no?
Yes,
Yes,
sir.
sir.
E2 elimination with carbon ion character. Yes or no?
Yes, sir.
So we have to take that hydrogen, which will be the giving the most stable carbon ion. That beta hydrogen which gives the most stable carbon ion. See, this is that beta hydrogen, this is that beta hydrogen, this is the beta hydrogen, this is that beta hydrogen. If the negative charge is here, then it is delocalized to benzene ring. So that will be the most acidic beta hydrogen, even the most stable carbon ion as transition state. Yes or no?
Yes, sir.
So the answer should be the alkene P is this. Yes or no?
Yes, sir.
So its molecular weight is 104 divided by 9. You'll get 5 as remainder. Is it clear?
Yes,
Yes.
sir.
Okay. After this, 28 is done.
27, sir.
27 is a doubt. Okay. See, they are asking you to consider both the major as well as minor product. So major on bromination will give 2 chiral centers of 4, and minor on bromination will give 1 chiral center of 2. So total is 6. Is it clear?
Yes, sir.
Okay, that's very good. And 29, 30,
30, sir.
huh?
30.
30. So 30, you see, it is asking for functional group except C double bond C and C triple bond C. Except those, the functional groups are OH, alcohol, and COH. So A is 3. Yes or no?
Yes, sir.
Sodium will react with acidic hydrogens only. This is acidic hydrogen, this is acidic hydrogen, this is acidic hydrogen, this is. B is 4.
Yes.
See, NaOH will only react with, acidic hydrogen on oxygen, which can be delocalized. Are you getting a point? See, this is an alcohol. It will not react with NaOH because alkoxides are less stable ions than OH minus. This will also won't react. These two will react, right? So Z is 2. Yes or no?
Yes, sir.
And last, sodium bicarbonate test is only given by carboxylic acid, not by phenols or other groups here. So 1. Yes or no?
Yes, sir.
So I think after that the
So
mathematics.
can you say once again for NaOH?
NaOH. See, NaOH will only react. See,
Yes,
if
sir.
put a negative charge here, this can be delocalized, right or no? See, OH minus will be taking the after taking the hydrogen, the carbon ion should be more stable than OH minus. C minus won't be more stable than O minus. Yes or no?
Yes, sir.
RO minus will not be more stable than OH minus. Yes or no?
Yes, sir.
But these two will be more stable than OH minus. Yes or no?
Because of delocalization, right?
Yeah, that is why. So 30 is clear to all of you? Yes, no?
Yes, sir.
That's very good.
Sir, can you say 29th?
Yes, I can say 29. But this is a question which I think someone has asked me in the class itself, during question paper or whatever discussion. See, it is saying how many monocarboxylic acids will give isopentanous product alkene. Now you see, basically what happens in sodium lime decarboxylation is that RCOH gives R minus, gives RH. So basically what happening that one of the COH is getting converted into hydrogen. Yes or no? Yes, no?
Yes.
Yes, sir.
Okay. So I draw isopentane. This is isopentane. Okay. Now what are the unique hydrogens here? You can have hydrogen, this hydrogen, this hydrogen, this hydrogen, and this hydrogen. Okay. Now, if you convert this to COH, okay, so A, B, C, D. So if you are taking the A route, then you got COH, right? Take B route, COH, you take C route, COH, you take D route, COH. All these will be giving isopentane only, yes or no?
Yes, sir.
Now how many such products are there? This becomes a chiral carbon, so 2. Here there is no chiral carbon, so 1. Here again this is a chiral carbon, so 2. No chiral carbon, so total is 6. Are you getting a point? Yes or no?
Yes, sir.
Yes, sir.
That's awesome. Okay, so 30 is done. 29 is done. Yes, no?
Yes, sir.
Okay. Anyone has any doubt in 26 also?
No, sir.
Okay. So this brings us to single correct section 3, which is 3 by 3. You have one correct answer. Okay, so then you have to evaluate the option which of them is incorrect combination. 1, 2p. Okay, one is this, 2 is addition of hydrogen, p is syn addition. So 1, 2p is correct. Yes or no? So they are asking incorrect. So then you have 3, 1q. 3 is this, 1 is Br2, and Q 3, 1q is also correct. Bromination is anti. Yes or no?
Yes, sir.
Yes, sir.
Then 4, 2q. 4 is this, 2 is addition of hydrogen, and Q. It's addition of hydrogen would be syn addition. Yes or no? In case of alkenes, there is no way of getting an anti-product. So 4, 2q is the wrong one. And 2, 1q. 2 and then 1 addition of Br is anti. So 2, 1q is correct. Getting a point? Yes or no? In this case, you have to, it's better to evaluate option wise. Are you getting a point? It will be faster. Okay, because each one is having all the 4 possibilities, so that is right. So, any doubt in 31, 32, 33? Any doubt in 31, 32, 33?
No, sir.
Okay. Then same in case of 34, 35, 36. Again, you have to, here it is to prepare this as measured product, what will be the correct combination?
Sir, 36.
36. So to prepare 36, what is 36? 36 is to prepare this as major product. What is the major product? Okay, which is the incorrect? So 3, 2p. What is 3? 3 is this, 2 is this. So this will be doing E2 elimination, so it will give this product, right? So that is correct. Yes or no? Then 3, 3R. 3 with 3 and again R. That would also give, because it is EC or EI, it will give esters. Is it clear?
Yes, sir.
Are you getting it or shall I draw it?
Sir, the third one, can you do it? I mean, the 3, 3R.
Okay, 3, 3R. Okay, let's see. What is 3? CH3, COCl. And this is an ester group. It will take a beta hydrogen and you'll get an alkene. Yes or no? See, ECI is also a beta elimination only. Only thing is there is syn elimination instead of anti.
Yes, sir.
Are you getting a point? So you will get this as a product. Is it clear to all of you?
Yes, sir.
Yes, sir.
Earlier I was thinking of evaluating the option, then I got bored. It's faster to just check it. Others are clear? Yes or no?
Yes, sir.
Okay. Any other doubt in this paper? You are free to ask.
The 26th.
26th. We didn't discuss 26th. Yeah, tell me which one. This one. See, when you have dinitrobenzoic acid, it is having higher pK, higher acidity than this because there are two NO2 groups. This is a, like database thing.
Yeah, okay, sir. And HCOH?
SUH will always have more than benzoic acid, no? I have given this point, SCOH, this is a database thing, then 5COH, then CS3COH.
Okay, sir.
3.74, I think it's like 4.2, and this is like 4.74. This I have given.
Why is it getting the stability in that HCOH?
There's no way of predict. I have told you this thing that there are competing effects here. So there's no way of establishing it through logic. You have to go by data. Is it clear? Yes or no?
Okay, sir.
Okay. Any other doubt in this whole paper? Any other doubt in this whole paper?
No, sir.
No. That is very good. So can we conclude this paper discussion?
Yes, sir.
Okay,
Yes,
I'm
sir.
proud.
Yes, sir.
So you see, with this, we have finally finished everything which is related to GOC. I feel that this is the last paper which are GOC, based on GOC and tautomerism. So after that, most of the papers which are going to come will be reaction based. Are you getting a point?
Yes, sir.
Yes,
Okay.
sir.
So now the things will be much easier actually. Well, I don't consider GOC to be tough, but the thing is like there is a lot of experience required for GOC as compared to the other topics. Is it clear? Okay, so let me just finish the recording part.